Hey, AP Chemisters, this is Mrs. Vanderlei bringing you part 2 of chapter 1.7. We're in the midst of doing calculations with sig figs. I had asked you to do these problems already, and I am in the midst of going over them with you. So hopefully you've already completed them, so let's keep going and see what you got, okay? Or at least see what I got. So over here in part 3, let's see here, I kind of made a mess here. I first did the parentheses, and when I used my calculator, I got 0.3455, but hold on. This 5 is in the 10,000 spot, and that 3 right here is in the 100 spot, so I rounded to 0.35, and then I did the rest of it, the multiplication division, so I had this times this divided by 0.35, and the rule when you do that is how many? So I have 4 sig figs, I have a lot of sig figs, I think 6, and I have 2 sig figs. So this is what my answer my calculator gave me, and I rounded to 2 sig figs because of this term right here. Why does this have 2 sig figs? Because that's what happened when I subtracted it, and I used the least accurate spot. Okay. And number 4, I did the parentheses first, so I did this, and when you multiply, you count how many. So this is what my calculator gave me, and then I rounded to 2 sig figs right here. And then I took 8.2 minus 8.02. My calculator gave me 0.18. But hold on, this is in the tenths, this is in the hundredths, this is my least precise spot. So my answer is now 0.2. I had to round 0.18 to the nearest tenths to the 0.2. All right, let's see what my next spot gives me. Okay, there we go. Right here, this is pretty straightforward. There were no parentheses, so I just went ahead and I added and then subtracted, but hold on to what place value should I have this? This is in the thousands, tenths, hundredths, so I need to round this to the nearest tenths. So it's right here. So, oh, what happens? I have to round up to 121, but I still have to have it in the 10th spot, so I have a 0 right here. So it ends up being 121.0. Over here, I first divided this, okay, and I got 0.81 here. Why 2 sig figs? Because of the 0.31. Then I took 0.470 divided by here, and I have 3 sig figs no matter what. And then I have 80.705 divided by 0.4326, and I got with 4 sig figs because of this bottom term, the denominator. So I'm going to take 0.81 plus 0.754 plus 186.6, and my calculator gives me 188.164. But now to see where I have my spots, I have a hundredths, thousandths, tenths, so I need to make this to the nearest tenths, and there I go. Okay, that's not too bad, is it? Let's go to the next page and see what we're going to do. So I'm not sure if you've done 7 and 8 yet. If you haven't, pause this and try it. If you've already done, let's go over it. So once again, I do the parentheses, okay? All right, here we go again. Sorry I was interrupted. So I have this 18.7 minus 17.1 is 1.6. Then I took 2.91 divided by 1.6 times 6.404. This is what my calculator gave me, but now I have to look at how many sig figs in each term. I have 4 here, 3 here, and 1.6 has 2. So my final answer has 2 sig figs, so it's 11.64, whatever, rounded to 2 is 12. Now what I did in number 8 is I went ahead and put everything in normal notation, not in scientific notation. I did that so you could see where each term is. I'm trying to move this over here. Move. There we go. So where is the, now I kind of got lost in the terms here, so I just counted my decimal points. Here's 4, 5, 6, 7, 8. So the one's in the 8th spot. 1, 2, 3, 4, 5, 6, 7. The 2's in the 7th spot. 1, 2, 3, 4, 5, 6, 7. The 1's in the 7th spot. So 7 is going to be my key number. So when I subtract all this out, I get this number, and the 4 is in the 7th spot. So it's in the least precise spot. So that's how I would do those guys. It says no calculator using the rules of sig figs. Calculate the following. Go ahead and do that. See what you get. So remember, there was no calculator. So if you look at your answers, you'll see this is probably what your calculator would give you right here. So what would be my final answer? Well, this is in the thousands, this is in the 10,000s. I need to be in the thousands spot, so D is your final answer. I hope you got that. So we've been talking about precision and accuracy. We talked about that. We talked about our equipment from the other day. And accuracy is how correct it is to the true value. Precision is how close they are to each other. Okay, so how can you reproduce those? So can we worry about that with equipment? Sure can. What if my scale is not balanced correctly? It should be very precise, but it may not be very accurate if it's not correctly calibrated. If you are looking at a burette and you're really short and you're not looking at eye level, you're looking at an angle, you'll probably be very precise but not very accurate. So these are the kind of things you need to be thinking about when you're looking at equipment. So over here, here's a graph, determines each student's accuracy and precision. Well, the true value is this pink line right here. The average is 10.13, and it should be at 9.92. I'm sorry, the average is the pink line. The the true mass is right at 10, excuse me, the true mass. So is it pretty accurate? It's not too far off. I would say it's fairly accurate. How precise is it? Look at those values. They're all over the place. I'd say the precision is very poor. What about student B? The average is 9.79. It's a little bit below here there, so I'd say the accuracy may not be all that good. The other person is a little bit better, has a higher, or is closer to the exact value of 10, but student B is about 0.21 below that. So I'd say the accuracy is lower than student A, but look at the precision. The values are pretty close to each other, so I'd say that value for student B or the precision is pretty high. So if you look at student C, well, probably no duh, the average is 10.01. The average is very close to the true value of 10. And if you look at all those values, they're really, really close together, so student C gets the gold star. They're both accurate and precise. So it says explain the following statement using two examples. You can be precise but not accurate. I've already given you examples. If your equipment is not calibrated, you know, you could have very similar answers but not close to what it should be. It says if you are accurate, you are necessarily precise. I disagree. If your average works out to be the true value, but your answers are all over the place, you are not precise. So the second statement I disagree with. The first one I agree. Down here it says two chemistry students are each drinking a canned beverage. The volumes of both cans are listed as 300 milliliters. Steve marks the bottlers that must be precise and hopes to get pretty close to that in every can, which would be a correct response from Susan. Okay. If a precision were the only goal, the bottlers would claim any volume as long as it was always very nearly the same. If precision were the only goal, the bottlers would have to get exactly 300 mils in every can. If the bottlers want to be precise, all can volumes would have to average 300. Which statement would Susan have if it's just hopes to be very precise? The answer would be letter A. Okay, that's the only one that's talking about just precision. Letter B, then that would be precise and accurate, and letter C is just accurate but not precise. Okay, hopefully that helps. So that is the end of section 1.7. I hope this was good for you. I hope that you remembered your sig figs. I hope you remember your accuracy and precision and why we worry about that. So I'm done. So don't wait to be great. Bye.